Hello, everyone. What would you think if I told you that it is possible to stealthily create invisible accounts on Windows systems? Hi, I'm Sebastian Castro, and today we're going to be discussing this question with this research called Suborner, a Windows bribery for invisible persistence. I'm super excited to be here. This is a research I released 2 weeks ago in Las Vegas at Black Hat. And today I'm expecting to share more details about this new attack. So I hope you enjoy this talk as much as I do. So this is a little about me. I'm InfoSec nerd. I've been working in the information security field for about 10 years. I'm terrible at Microsoft Paint. You will notice that later, but I use it to explain myself better. I'm doing my PhD in computer sciences, and also I'm working currently with the Product Security Office R&D team at AMD. And I have presented before at different conferences like Black Hat, besides Darbycan and other talks, other conferences. This is a little disclaimer. This is research that belongs to me. It has not to do with any of my responsibilities with my current employers. And every bad idea, every bad joke does not necessarily represent my employer's ideas. Brief acknowledgement. Thank you for everyone that supported me, family and friends, researchers that have contributed to this area. That for sure has helped me to be here. Especially, the people that have developed the Mimikatz, Benjamin Delphi, the Impacket team, the Microsoft team. I've been discussing this attack with the Microsoft Incident Response team, then the Stack Overflow, of course, and the InfoSec community. All right, so this is going to be the agenda of the talk. First of all, I would like you to understand exactly why I believe this research is important and why I decided to start this research of trying to suborn Windows. After that, I would like to explain you what is this new attack, what it's all about, and share some details about the attack itself. In the middle of the presentation, I'll probably deep dive into the details of how I ended up finding a way to create some, this kind of stealthy accounts. I'm planning to do later a live demonstration against the latest Windows 11 system. I have just updated it like 30 minutes ago. So I'm planning to do a live demonstration. I like the more the videos. So hopefully it's going to be going good. And after that, we're going to discuss about what's next for this attack. All right. So let's start it. So let's talk about first why I decided to start this journey. So back in the day, like 2007, when I wanted to become like a lead hacker, when I was starting, pretty much one of the very first Google queries I did was how to create an invisible user on Windows. And despite of trying so hard to find a way to create an invisible account, I couldn't find something that actually helped me out to create an invisible account. 15 years later, if you do the same query in Google, you'll get around 439 million results. So ideally, you would expect, okay, probably someone has found a way to create invisible accounts. So yeah, let me show you some of the the answers of these questions that you will find in Google. So this is a post from the Windows Club where someone is claiming that you can create a hidden administrator account by creating this bat file. So everyone that knows a little about Windows knows that actually this does not create an invisible account, right? So probably this is not the best way to do it. What about this? Apparently someone else is trying to figure out a way to create invisible account as well. In this case, this user wants to create an administrator account hidden, right? And then we see that a 10 years awarded Windows MVP says that he only knows 2 ways to create invisible accounts in the Windows systems. And apparently they only are hidden from the sign-in screen, which is not ideal, right? In a more corporative perspective, if we think about the MITRE attack framework that covers 19 persistence techniques that I have classified as identity manipulation and external implants, and none of them actually refer to ways to create invisible accounts. So let me show you. I have classified these 19 persistence techniques as identity manipulation, which has to do pretty much of modifying the identities that are being used in an operating system or any piece of software. In this case, they're referring to account manipulation, create accounts, and valid accounts, which involve attacks that are familiar to all of us, like golden tickets, silver tickets, simply creating a new account, and things like that. And there are a whole bunch of different persistence techniques that are referring to external implants that actually require to install an additional software to the victim. So it can be, patching something in the registry, creating a new service, even compromising the, firmware, things like that. So it's additional software, right? So from all of these persistence techniques, if we take a look at the unique procedures that are being described in the MITRE attack framework, 63 of the 85 unique procedures, which is pretty much the APTs that are being described as a way to explain these persistence techniques in MITRE, 63 of the 85 use somehow an identity manipulation. So definitely the identity manipulation persistence techniques are the way to go. They're being used by many adversaries right now, and that is why there has been so much research about the identity manipulation. So we know a lot of tools like Mimikat, Rubius, Impackets, a lot of tools that are modules that Metasploit implement to try to modify the accounts and the identities that are being used in the operating system. And I mean, this is expected because that's the process that the actual operating system uses to give permissions and privileges to their users, right? But what's the problem here? As far as I know, none of these tools actually craft an invisible local user on Windows systems, right? They can for sure extract some sensitive data from the accounts, like the NTLM hash, some cached hashes, but none of them can actually craft or create a hidden local account, right? So what is the Suborner attack? Suborner persistent attack is a new persistence technique that will allow us to stealthily forge custom invisible accounts that will have the capability of impersonate any identity that is already in the victim, and it's going to work on every Windows NT system. So this works from Windows XP to Windows 11, and this works from Windows Server 2003 to Windows Server 2022. I haven't tested this on Windows 95 for obvious reasons, but ideally this would work on all of them. I've tested this in all the NT operating systems. So the idea with this attack is that only who created the Suborner account will easily know the username and the password. This is the authentication process. And after the authorization, the Suborner attack will impersonate any account that is already there. So we are getting stealthy right in the process of the authentication, and we are getting some stealthiness after the authentication and authorization. So this is how it looked like. I'm going to be brief here because I am going to be sharing some details about this later. So this is what we are doing. We are pretty much creating something that looks like the machine account. We are specifying the password, we're specifying the RID of the account. And here we see that we have just created this account. And after that, if we try to authenticate to the victim with this new pair of credentials, we will see that in this case we are using PSExec, the Impacket's version of PSExec. We will see that we will get a system command prompt, a remote system command prompt, and we will see that this new account is not going to be visible in the net users interface. We're going to be deep diving this a little later, but this is the whole idea. So before talking about how was this process done, let me share with you how it's usually the creation of accounts and manipulation accounts here. So to do this, I would like you to think about this super basic scenario where we have an attacker that has already compromised a victim, but there is an administrator that is constantly looking inside this victim for any indicator of compromise. So let's start simple. Let's take a look at the very first initial scenario, which is pretty much adding a new user. I think everyone here probably has done this, creating a basic user via the command prompt. So if you add a user via the net user application, you can do it super easily. That's the API that is exposed by the operating system for you to create the account. So you do this, you create this new identity that you can use to access the machine later. But unfortunately, this is going to be reported as a Windows event. In this case, it's going to be the 4720 event. And of course, this is easy to spot by an administrator or an EDR or any solution that it's installed there. If the administrator takes a look at the net user's interface, it will see that this new account has been created. And of course, it's going to be super easy to remove the access to the adversary, right? So this doesn't work. So let's see what happens if we append the $sign. So this has been a technique that has been recently popularized by some researchers like Ben 10 from Trusted Tech. And the thing is that when you create a username, an identity that has a $sign appended and is in its username, this account is going to be interpreted by the operating system as a managed service account. So if we try to do the same thing, net user, but only adding a $sign at the very end, we'll get the same event registered in the event log. And it's going to be a 4720, but if the administrator wants to take a look at the net user's output, there's not going to be like the account we have just created, but the event, it's going to be registered in the event log. Right? So in this case, it was a slightly more stealthy, but it was easy to spot due to the analysis of the Windows event log. So again, it's not possible in this way to create an invisible account, right? So this also failed. So let's get a little more advanced and let's try to create a machine account by directly calling the net API 32 function netuseradd. So what we need to do it's pretty much create this structure that will contain all the data of the account we want to create. So as you can see here, we need to specify for the user info one, for instance, this is one of the structures that you use to call the netuseradd function from the net API 32 API. You need to specify the username. You also specify the privileges, which in this case is 0, 1, or 2. This will define if the user is an administrator, a username, or a standard user, or a guest. And you specify the flags that will define the type of account. So in this case, 1000 stands for workstation trust account, which is the flags that represent a machine account. So if we do this and we craft somehow an executable that will try to create this account, and we execute it, this is going to be registering a different event. In this case, it's going to be 4741, which is less commonly monitored as 4720, but still it's going to be registered in the account. If the administrator takes a look at the net user's output, the account is not going to be there, but it's also possible to see that someone created an account with this different identifier, right? And of course, it's possible to remove the access to the adversary. So none of these three scenarios work. So what is wrong? This body account is detected right after its creation through the Windows events, or if there's something like an EDR that is something like API called sequence analysis, it's easy to spot that someone has invoke the API that's intended to create new accounts. And it's also easy to spot after its creation, but some user management applications like the net users. And what's the thing? If you want to persist a high privileged access, you will need to add this account to an admin group, which is also easy to spot. And the other problem is that the API that is used to create new identities impedes to modify all the attributes that are actually involved in the account creation process. So what can we do? It would be ideal to find a way to, just bribe Windows and say, why when we create an account without, reporting that to everywhere in the event log and things like that. And to do this, we need exactly who to bribe in the authentication and authorization process. So if we take a look at a high-level overview of how the authentication and authorization process works for Windows, this is a high-level. These are like the credentials management applications that are being used to create accounts. In this case, we are using the netuseradd API. So if we try to create an account, we're going to be communicating to this API. Then the information is going to be sent to the LSASS process that will try to query the LSA policy to define the way we are going to be creating this account. And after that, if everything went well, all the account information is going to be written into the SAM. So this is the important part here. All of the details of the local account are going to be registered in the SAM. And right after this, the LSASS is going to be calling the event logger that is going to be reporting the account creation. And if everything went well, the account is going to be done. So this is a high-level overview of the process. So the idea of the Suborner attack is really simple. Now that we know this, why don't we try to write the SAM directly with the data that we already know that it's needed for the operating system to create a new account? And let's say try to pay a bribe to the event logger to not say anything. This is the whole idea of the attack. It's super simple. So we try to write everything of all the account information to the SAM without calling the event logger, and try to make this account as stealthy as possible. So I'll try to explain all the details later. So the Suborner attack dynamically crafts this Suborner account without using the Win32 API. In this case, for instance, the netuseradd. We are adding some extra stealth to the Suborner account by appending this $, because remember, every account that has this username with a $sign appended is going to be interpreted as a managed service account. And we are going to be leveraging something that is called the account control bits that will define the type of account we are creating. All right, so that's an overview of the whole attack. So let me talk about the process. I already had this idea, so I would like to develop it. And this is like when the struggle begins. So what I try to do first is try to understand the authentication and authorization process for local accounts, right? So this is the high-level overview that I have just showed you. But actually, this is a little more complex. If we take a look at some of the modules that are actually involved in the process of an account creation, there's a lot. You can see that the credential management applications involve many DLLs and many executables that we are not going to be discussing right now. We can see that also we are seeing some authentication providers that are related to the Active Directory authentication. In this case, we can see that there are some authentication providers like the Kerberos DLL, the KDC service.dll, and we also see that there's a communication to the domain controller via the NTDSA DLL, but we don't care about that right now because we are focusing on the creation of a new local account. So we can ignore them for now. So we would like to focus on the authentication provider MSB1 ODLL, which is in charge of the authentication, creation, and communication with the SAM service to create local accounts. We're going to be talking about the security reference monitor and all the credential management applications that are being involved with this process. So let's make it simple. Let's try to go step by step with the authentication process for a local account. So whenever we try to authenticate against a Windows system, we can do it with different type of, let's say, inputs. We can specify a username and a password. We can do it with a PIN. We can do it with a smart card. And each of these processes uses something called a credential provider. So in this case, if we are using a username and a password, we're going to be using a specific credential provider. In this case, let's say that we are using the credential provider that it's intended to authenticate via username and password, the basic one. This is going to be processed by the WinLogon module that after processing the username and password entered, the credential provider is going to translate the password to the NTLM version of it. And after that, the WinLogon process is going to add a logon SID, which will describe this particular logon attempt for this username and this password for this specific event. After that, the WinLogon process is going to be sending this information to the LSA service, which will also try to communicate and send this data to the authentication provider called MSB1O.dll. In this case, WinLogon is going to be calling the LSA logon user function that will send this information: username, NTLM hash, and the logon SID that will describe the logon attempt. Then this information is going to be sent to the SAM service, which will try to retrieve all the information of the account. So pretty much what SAM service does here is try to verify that there's a username that exists with this inside the SAM database, and it will verify if the password, the NTLM hash actually matches. If everything went well, the SAM service is going to say, yep, everything apparently it's good, and the MSB1O it's going to validate the information that has been sent against the information that has been stored in the SAM registry hive. And after this, since we had a successful authentication, the LSA process is going to report these to the event logger saying, okay, someone authenticated successfully, and it's going to register. It's going to be registered. The event of the authentication is going to be registered in the security log. After this, the authorization process starts. So now that we had a successful authentication, we had a username, password with a specific logon SID that will describe this logon attempt. And since it was successful, the LSA process will append this LUID identifier for this session saying, okay, I am creating this, I'm starting this authorization process for this particular logon SID attempt, and this LUID will describe this process. So what is going to happen is that the security reference monitor that is being, there's a communication between the LSA process and the security reference monitor that starts at the very beginning. It's an ALPC connection. They are going to be communicating together to forge what will describe the principal, the primary access token. The primary access token is going to be the way that the operating system has to describe the permissions of the account, right? So in this case, after a successful authentication and the start of an authorization, there's going to be creation of the very initial access token. And then, after that, the the LSA as a service, it's going to try to add some of the additional permissions that this initial access token doesn't have. Based on the policies that are described in the LSA policy, all of the permissions of this username are going to be appended to this access token. So pretty much, this is the process. It's a high-level overview. So what we need here is a username, we need a password or an NTLM hash, and we somehow need to know exactly how to craft the access token. This is the basic idea that we need to know to successfully create a standard account, right? So now that we know that, what I did later was try to create a local account writing directly to the SAM. So what we need is a username, an NTLM hash, and somehow try to craft this access token that will describe the security context of the user after a successful authentication and authorization process. So we know also that this information is somehow stored in the SAM, right? But we don't know initially exactly where. So what I did here is, okay, this is how the registry hive looks like for an account that it's in Windows 11. But what I did is pretty simple. I travel back to time and I tried to analyze how the SAM looks like in a Windows XP machine. And they only have these two particular entries, which are the F entry and the B entry, right? So what I guess is that, okay, probably the information I need, it's only there. What's the problem here? Of course. So if we take a look, for instance, at the B binary, we don't have like an actual structure of actually how the information is stored in here, right? So one of the processes that I did was try to recollect as much information as I could from, internet resources and reverse engineering, and try to to describe the structure of this B file. So this is how the structure looks like. As you can see here, there are a lot of information like username, the full name, the comment, and there's also a version of the LM hash and NTLM hash and NTLM history stored in here. And one of the problems here is that the V size is dynamic. And this makes sense because, of course, the username values and comment values like this, they don't have a specific fixed size, right? So the structure actually looks like this. If we take a look at the username, we'll see that the very first part contains the headers of each value. If we take a look at the header, the structure is going to describe initially an offset from the OXCC, let's say, address inside the binary. It will also contain the length in Unicode of the value that we are storing. And there's like an unknown value that is also stored in here. Because, remember that Windows is closed source, so of course these structures are not, open source, so we don't have access to them. So this is pretty much how it looks like. For now, I don't know what this unknown field is intended to, but it's not necessary for our purposes. So this is how the headers look like, and then the values are in the offset from OXCC. If we take a look here, in the particular case of the username, we see that F4, which is 244 decimal, it's going to be pointing to the actual value of the username field, right? So in this case, this is the Suborner and the $sign Unicode version. We'll see that the length is 18, and we don't care about the unknown value. So we know that this is the structure of the B value entry, right? This is pretty much how it looks like, but remember that we don't need to actually try to understand all of these values. We only need to understand the username and somewhat the NTLM hash. So we know that the B binary is going to contain the username and it's going to contain the NTLM hash. So I know how to craft a username, but the NTLM hash was a little more tricky. So what I did was try to understand how the tools extract the NTLM hash from the SAM. So I tried to analyze, okay, what does Mimikat do when trying to extract the secrets from the SAM, Packet and Metasploit, and try to analyze how this SAM hash is used to store the NTLM hash. So what's the problem? In the SAM, the NTLM hash is not stored as it is. There are some ways that the operating system converts it from NTLM to a SAM hash that it's unique for each system. So what I did is pretty much try to extract the information, try to analyze how Mimikatz, for instance, extracts this information, and try to replicate the process that the operating system does to actually convert from an NTLM hash to the SAM hash that will actually contain the password, that it's going to be a unique SAM hash for each system, right? So this is how the process looks like. Initially, it will verify if there's a Windows 10 version 1607 or greater. Then it's going to try to calculate the NTLM hash. So in this case, we're starting from the password to the SAM hash. So we're going to calculate the NTLM hash, and it will split it in two halves. And each of the halves is going to be calculated with a des key that takes some information that it's unique for each operating system, like the boot key and things like that. And all this information is going to be encrypted and concatenated as a new des hash. And then it's going to be the calculation of the SAM key that is going to be pretty much used to calculate the very last SAM hash. So before Windows 10 1607, Windows used to use MD5 to do this hashing. After that, they are using AES. So this is why we are doing the validation if the system we are attacking is Windows 10 1607 or greater. And after calculating the SAM hash, we know for sure that we have crafted successfully this Windows system. So the conversion from the NTLM hash to the SAM hash key, right? So after this, we are going to try to write these changes to the B structure, right? So this is how it looks like. Process we have just done is try to write the username to the B file. We try to convert the NTLM hash to the SAM hash key and try to store it in the B binary. But what we do with the way to describe the security context, how can we try to somehow patch the permissions that we want to impersonate in the registry hive? So after trying to create an invisible account, what I did is try to make it invisible. So now let's take a look at the if-f binary. The F binary, it's easy because the size is fixed. So this binary does not contain any particular dynamic, let's say, all the sizes of the values here are fixed. So it's easy to forge. But we're only interested in two particular values here. The first one is going to be the RID copy that this is going to be used by the security reference monitor to actually craft the access token. And we're going to be interested in the account bits that will pretty much describe the type of account we are going to be creating. So what I did to impersonate an account is to leverage an attack that I released 4 years ago, also at Black Hat 2018, which is called RID hijacking. So what we do with this attack is we abuse the way that the security reference monitor crafts the primary access token. And the problem with the way that Windows creates this access token is that they base this creation on this particular RID copy that it's stored in the F binary. So what we are doing here is specify what is the account that we want to impersonate. I'm not going to deep dive in the details of the RID hijacking. If you want to take a look at it, there are some blog posts I have written about it. But this is what we are doing to pretty much impersonate any account that it's already there in the system that we are attacking. Okay? So to sum it up, what we are doing is, okay, we are somewhat forging the access token to impersonate any account in the system by leveraging the RID hijacking attack. We are also creating a username with an appended $sign and try to write it to the B structure. And we are, And we are also writing the data of the password to the hash, to the SAM hash, and writing that to the B structure, right? But wait, yeah, there's more. So after this, what we tried to do was analyze exactly how the NetUser API actually describes the type of an account and how the type of account we are creating and how this reflects in the SAM. So what I did is pretty much analyze, okay, this has to do with the account bits. So this is pretty much the values of the current values that are being used to describe some of the account types that we can create in the operating system. So what we are doing here is try to understand, okay, if you remember the example that we took a look at the very beginning when we try to craft our own account by specifying the privileges and the flags, what happens is that the netuseradd function is gonna write the type of account in this particular part of the F binary. So if we change this value to, let's say, 80, this is going to be interpreted as a machine account, right? So to sum it up, the simple way to see the Suborner attack is this. So we have a username that is going to be appended with a $sign, so it's going to be interpreted as a managed service account. We're going to try to craft the NTLM hash and to a SAM hash and write it directly to the SAM. We are going to somehow leverage the RID hijacking to actually impersonate any account that is already there. And we are going to leverage the account control bits to describe this account as a machine account. So that's the Suborner attack. In this case, we successfully created a custom account without using the Win32 API limitations. And as you can see, we could modify some of the attributes that are not modifiable through the Win32 API. Right? In this case, for instance, we're modifying the RID that is being used for the primary access token generation. So, okay, it's demo time. This is what I have developed to automatize the attack. So what I did is create a C# solution that will forge this account. It will try to craft all of the SAM register keys that will describe an local identity without the limits of the API, and it works on all Windows NT systems. So these are the parameters of the current tool. Right now we can specify a username, we can specify the password we want to set to this account, we can specify the RID of this account. We can also specify the account that we want to impersonate. We are going to copy some of the values of an account that already exists there, and we can set that in the template parameter. And we can also decide if we want to create this as a machine account or no. This is going to be the demo scenario. It's going to be super simple. So it's going to be an attacker machine. and a victim machine. It's going to be a Windows 11 system that I have just updated like 1 hour ago. I do like the excitement of live demonstrations instead of videos. So this is going to be the attacking machine. It's a Black Arch Linux, super simple. This is going to be the IP address of the machine. So these machines they have visibility one to each other. And this is going to be the Windows 11 system we're going to be attacking, right? So let's take a look first at the users that are here. At users, we'll see that we only have an administrator account. We have the user account that is the one we are using. Remember, this is a persistence attack, so we have already compromised the system. We are trying to backdoor somehow the system in a stealthy way. Let's take a look also at the L user manager. So this is going to be another user interface that will show us what identities are here. We see that we don't see any weird identity here. If we take a look at the administrator, this is going to be the account that we are going to be impersonating. We see here that this account is disabled, but still, despite of being disabled, we'll have the capability of impersonate this account, right? Let's also take a look at something that is really important. Let me show you that this is an updated Windows system. So I updated it like 1 hour ago. Let me show you the patches here. System info. So these are the patches. If you want to double check. Oops. Okay. All right. So let's also take a look at the Windows 11 user management interface. So if we take a look at the users here, other users will not see any particular account. So yeah, we only have these accounts. And let's also take a look at the event logger. This is the current status of the event logger. We don't see any particular strange event. So let me update this real quick. There you go. We don't see anything weird here. Let me sum a little bit. This is the current status. We don't see any particular event ID. I'm sorry about that line. I told you I'm terrible at Microsoft Paint and, drawing. So yeah, this is it. So what we are going to do is try to create a Suborner account, right? So I'm going to be using crackmapexec to validate that we have created this account. So this is the target IP address. The account we are going to be creating is Suborner $, and the password is going to be password.1. And we are going to be trying to query the LSA secrets, right? So let's try to run this command just to show you that I have not somehow created this account before the demonstration, right? So we'll see here that for sure we don't have access. We see the status log on failure because, of course, this account does not exist, right? So if we try to suborn Windows, we can use the solution. I have double out on C#. You can specify the username. In this case, it's going to be Suborner. Let me extend this a little bit. And password is going to be password.1, right? And we're all set. We have just created our own account. We can see some of the details here. We are creating this account, Suborner $. We're specifying a password. The RID is going to be automatically assigned based on the accounts that already exist there. by default, it's going to be trying to impersonate the 500 RID account, which is the built-in administrator, and it's going to try to copy all of the other attributes of the account. And we're going to specify that this account is going to be a machine account. We are creating the account, we're forging each the F key and the B key, we're encrypting the password and writing the changes to registry. So yeah, let's take a look at first at the event logger. So let's try to see if there's any change here. Okay, there's something. What is this? So this is the CrabMap exec attempt that we had early, right? That's the only change we have, right? But aside from that, we don't see any, 4720 or any particular event that describe that an account has been created, right? Let's take a look at the account itself here. Yeah, net users. So we're going to see that there are no any Suborner account. We have the same accounts that we had before actually executing this program. If we take a look also at the user interface here, let me open this again for it to refresh. We're going to see that there is no Suborner account here either. The administrator account, this is still disabled. We haven't changed that, right? Let's take a look also at the Windows 11 user management application, which is the users, other users. So let me try to jump to accounts. This is going to be a user and, and family and other users. Yeah, we don't see the account we have just created. But if we try to run this command again, same command, user, suborner, password, and LSA, we're going to be successfully connecting to the account and retrieving the LSA information, right? We can also try to connect with psexec with the same account, suborner, password.1, specifying that we successfully have a command prompt, a remote command prompt with these particular credentials. If we take a look at net users, we will not see the account even after a successful authentication. If we try to take a look at the actual, let's user suborner, we'll see that there's no such user suborner, right? We take a look at the net local group administrators, we'll not see our Suborner account, but despite of not being there, we have successfully got high privileged command prompt against the victim. So this is how it looks like. I'm glad the live demonstration worked well. So yeah, let's jump back. I like the excitement of doing live demonstration instead of videos. So yeah. Of course I had a video, just a backup, but yeah, I'm glad it worked. So yeah, so what's next for this attack? Of course, I communicated this to the MSFT incident response team. I talked to them before releasing this to Black Hat, and they told me that this is a persistence attack, and it makes sense. We have already compromised the system. This is not considered as an actual vulnerability. It's more like, it's a persistence vector. So I would think that they are not planning to patch this in the near future, right? So it's all bad. So 1 month ago, I was thinking that probably this type of accounts can be leveraged and as a, let's say, offensive defensive way to trick adversaries. Let's say you can be a sysadmin that can try to forge one of these hidden accounts and hide them from adversaries, and you can use them to pretty much try to run services or anything that is useful for your the functionality of your system. This, of course, can be detected by inspection. I know for sure that some friends of mine are working on finding new ways to detect this, the pattern that the current solution, Suborner solution, tries to leverage. But ideally, what I'm trying to do is, improve the way that we are forging these accounts. So the automated detection is going to be harder, ideally, in the future. And even though this is not a local account, it's definitely useful in Active Directory environments, right? Of course, this doesn't work against domain controllers because the authentication there, it's different. We don't actually use the MSB10 authentication provider. So there's not actually, you cannot patch directly a domain controller, but you can patch anything like a server, a worker station it's already there. So what's next? Ideally, what I want to do is, I don't want to rely on the Win32 API to create local accounts. What I want to do is pretty much have total control of each of the attributes that a local account has without relying on the API and its limits. This is the initial vector that I found. But ideally, what I want to do is use this somewhat like, let's say, like a harness for fuzzing and try to find if there's any particular different type of account that we can create based on the attributes that now we can control, right? And probably this can be useful to find. Right now we are creating invisible accounts that can be detected by some patterns, but probably we can end up finding any other type of account with different properties that we are not aware of, right? And that's it. Yeah, I hope you enjoyed this talk as much as I do. I hope you are as excited as me to try this new tool all for yourselves. And yeah, let's try to suborn the planet. And these are some references about the talk. And these are some details if you want to take a look at the GitHub repository of the tool. If you trust me, you can scan that QR code. And there's going to be the blog post. There's going to be the GitHub. Yeah, that's information. And thank you so much for coming. It was my pleasure, and I hope you enjoyed it.
Thank you. I think we've got some questions. So it's the only way to detect this is careful auditing of user accounts in the SAM registry.
As far as I know, yes. I know that there are some people working on some PowerShell solutions to actually analyze the way we are writing directly to the SAM. I know there are some solutions that try to trace, let's say, the registry values that are being used to craft the SAM hash. So whenever you are, let's say, using Mimikatz and you try to extract the secrets from the SAM, you need to particularly extract some values that are stored in certain places in the registry. So there are some tools that they're actually leveraging that. So for now, it's not only auditing the SAM registry in the sense of the user accounts data, but also let's say, the registry hives that are being queried by some tools like Mimikatz when they try to, for instance, extract the secrets and try to, decrypt the SAM hash to the NTLM hash. I know that there are some solutions that extract this data from different values that the SAM registry hives that have directly to do with the user account, if that makes sense.
There's a person who asked this question here. Okay, I'll give you a gift shortly. The next question. So it avoids the Windows user account creation event 4720. But when using the invincible account remotely, would there be a Windows user logon event?
So, yes. This is going to be interesting because the event is going to be registered not as the account we have created, but as the account we are impersonating, right? So pretty much what I am doing is trying to authenticate with the Suborner account, and right now I am impersonating the administrator account that it's disabled by default, right? So that's easy to detect. If someone is trying to log on with an account that it's disabled, that's kind of weird. But this is for the example, right? But if instead you impersonate an account that it's already there, the logon is going to be registered with that account, right? So of course, I'm sure there's going to be some tooling that will try to detect some weird behavior in the Windows event log. But for now, we are pretty much impersonating these accounts, right? So yeah, great question. So whoever who asked that, yeah.
Who asked that question? You as well?
Yeah.
Right. Can you log in via RDP and Windows logon screen too?
So yes, but this depends on the account you are crafting. As far as I have tried, machine accounts don't have the interactive logon that is being used by RDP and logon screen. So what you may want to do is create this account by setting the flag as a machine account as false. You will lose some stealthiness, but you'll have the capabilities of logging interactively via RDP and login screen, right? I'm trying to find if there's any particular account control bit that I can modify that will allow me to authenticate interactively and remotely, as we have shown here.
Do you know with those network-based logins, would there be logs or still no logs for 624, for 625?
You mean for interactive logon? I think it's going to be the same behavior. I haven't tried, interactive logons just yet, but my guess is that it's going to be the same behavior. But feel free to try and please let me know.
Who asked that question? Okay. And the last question: if the user account is so hidden, invisible, how then can such a persistent be removed or remediated?
How then? Okay, so ideally, what you want to do here is constantly monitor the SAM registry hive and look for any particular change in the registry hive that contains the user account's information, right? So we are actually crafting an account all by ourselves. So what you can do is, after monitoring if there's any change, any new account that has been created without using the netuser API or any API that is intended to create new identities, you should remove that, right? So this attack for now is creating new accounts. Ideally, what I'm planning to do, it's easy to detect, we have created an account, we have created a new identity, but with this, you can also somehow modify the attributes of the accounts that are already there, right? So that's the next step as well. I forgot to mention, but this question reminded me to talk about that. Right now we are creating accounts, but after this, we can try to use this tool to modify accounts that are already there. So we will get some more stealthiness without, writing a whole new account data. That solves the question.
All right. Thank you.
Any other questions?
Any more questions?
Sure.
Have you tried running Linux tools such as CHITB?
Yes. That's a great question. I think I mentioned that in the very beginning of the tooling I was talking about. They have described some instructions, some functionalities to actually change the NTLM hash. That tool is an open source tool that contains some of the structures I leveraged here to extract and write the data. I know that they can modify the password, and I know they can, for the latest versions of Windows, they can remove the password by removing the NTLM hash. The SAM hash key that is stored in the SAM, but they don't have the capability of creating new accounts. They have the possibility of writing a new password and removing the password. I think that's the initial intention, the principal intention of the program, like changing passwords. But yeah, I heavily I took some information for this tooling from the change password, the solution, the Linux solution. Yes.
Sorry, just to clarify, does it list your newly created account?
I'm sorry, what's...
Does it list your newly created account after you've run Suborner? And if you run
listen.
after that?
I haven't tried that. I haven't used that tool to detect this new account. But that's something that I could try. Yeah, I haven't tried that. I thought, okay, yeah, probably we can use that tool to detect this type of accounts. Yes, but I haven't tried that. Thank you.
All right, and we just have one more question that came up. Can Net API 32 be used to remove such accounts?
I haven't tried that. I mean, we can try that right now. We have to set up, but I haven't used, net user, this particular account on delete. I don't think it's gonna work because the account is not being listed. If you remember, we. Oh, you want me to try it? Okay, yeah, let's try it. Yeah. So, yeah, I don't know. That's a good question. Yeah, that's a good thing with the live demonstrations. You can solve. So net user suborner /del. There's no such user, so yeah. Apparently you cannot remove it. Good question. Yeah, but apparently you cannot remove them with this approach. Let's double check if we still have access. Yep. No, we're still there. So.
Could you show us the event logs from the last login, the remote login that you did?
Sure. Yeah. Let me see. Oh no, where is this? Oh, this one. Date here. There you go. Any particular thing you wanna?
I'm guessing that it's the special login that's being shown. Is that your account logging in? And does that show up as the administrator account now?
Let me see. Details. Oops.
It's fine.
Okay. Yeah, hold on. I don't. I mean, yeah. Let me show that later because I don't know what's going on. Hold on. I'm trying to, oops, but, oh no, I'm running out of time, but, yeah, let me show you right now. It's fine, but. Sure. Yeah, but yeah, thank you so much. Any other question you guys have? No? Sorry, okay.
Are you going to show it or are you going to show it outside?
I'm going to show them outside because I ran out of time, but yeah.
Sure then. Yeah, so who's interested to see that can
yeah, sure.
Talk.
Sure. We can do some experiments after to talk.
Let's give Sebastian another round of applause.
Yeah, thank you.